Hi, Dr. Robin here. Today we are talking about buret correction graphs. I'm assuming that you've been able to transfer your apparent volume and your actual volume into the spreadsheet, and that you can then set up the correction volume. You could see here the correction volume is defined as actual volume minus apparent volume over here. So you have these three columns. Now, you'll notice that unlike the tables that you have set up in your book, where you have these broken down into different sections, these are all presented in one mass. I usually suggest this. Here it would be extremely helpful if you could identify somehow which sets of data go together. So for example, this first set is for 10 mils delivered, and let's just give that a color. So I'm going to make that purple. So if you could go through and identify, you don't have to label, but color code, and again, you should be able to find the fill color icon somewhere on the home tab. So I have four sets of data here, each corresponding to an approximate amount dispensed by the buret, and that would be 10, 20, 30, and 40 mils. And what we're going to do is we're going to make the graph that you're being asked to make by the lab protocol. And to do that, we need to put the apparent volume on the X and the correction volume on the Y. And so this is one of those cases where, again, you can't just click and drag, because then it's also going to graph the actual volume, and we don't want that. So let's just go ahead and go to our Insert tab, find the Scatter Plots, and make sure you always use the one that does not have lines connecting it. This is really, really important. It is going to look so weird if you use any of the connector ones. You have to use the one that is points only. Okay, so make that graph, and you'll notice that I did not select any data for this. That is because we are going to be adding the data. And what I'm just going to do right now, I know mine looks very different. Yours is going to pop up with series. There should be an add data series button. So you just want one data series for now. What you're going to do, you're going to click and drag. The X values, again, are going to be apparent value. So I click and drag, hit return. Y, click and drag on the correction volumes. Now let's see what that looks like. You can see for this one, this is not linear. It is not going to be linear whatever we do to it. But you can see that these first three look linear. So what we're going to do is we're going to do trend lines. We want to do a trend line for this set, and we want to do a trend line for that set right there. So the first three sets of points are going to have their own trend line, and then this set right here, which is comprised of third and fourth, there will be another trend line there. Now if you go to this graph and you just try to put a trend line in, you can see it's going to try and do all of them. And even if you go to the trend line options, as we were talking about before, there's no way to exclude things from the trend line. So the way that you have to do this, the reason that this is weird, is that we are going to have to put these four sets of points in as different data series. And this is where it gets tricky. Again, we want to make one trend line here for these three sets, to make all these three sets linear, because that looks like it might be linear. So we want one trend line that goes for all this stuff right here. And then we want a trend line that runs between these two sets of points, which means we need these two to have a trend line. Okay, so keep that in mind. Here's my red graph. Okay, so what I'm going to do is I'm going to go back to my chart design tab. I'm going to go back to my select data button, and I am just going to delete the series that we just did. The reason I'm deleting it is because we need to put this in as two sets of data, the two sets that I just described. The first one, so let's add a series. The first one is going to be 1 to 3. And then the second one is going to be 3 to 4. Now you could see it's made them different colors. And you can go through, in the fill thing and make them all the same color. It doesn't really matter. But when you now go through and you add your trend line, you can see that it's going to do these. Now let's go through and add this one. It's going to do this as two separate trend lines because we broke the data into two sets. Now, why did we break the data into two sets? Because our data looked like it was pretty linear, except for the part that wasn't. And so we were like, here is how we're going to break it up. This part that's linear, that part that's linear. And of course, we would want to put the equations on here for each of the trend lines. Okay, so you could say, well, how did you know where to break them? Look, it really depends, and this is why I have you start off with all the data. It really depends on what your graph looks like. So I started out with a fairly simple graph where we broke the data into two chunks. Your data is going to do what your data is going to do. Or maybe I should say your buret is going to do what your buret is going to do. I have seen all sorts of buret correction graphs. I'm going to show you another one in case you get a really tricky sort. So here's a tricky buret correction data set. And you'll see what I mean as I make my graph. So again, we're going to start with the entire set. Oh, let me color code this. And again, it doesn't matter what colors you make everything. Just pick your favorite colors. Okay, so in this set we have 5 sets of data, roughly 10, 20, 30, 40, and 50 mils. And here, let's just go ahead and do our initial graph just to see what the data looks like. So let's go to our Insert tab, Scatter plot, scatter with no connectors. I don't want to see connectors on here. That's what your trend lines are for. Okay, and we're going to make this big. Okay, select our data. Correction, let's see. Add a data series. The X volume is apparent volume. the y values are correction. Okay. So this is not great, as you can tell. You look at this and you're like, how do I know where to draw the lines? This looks random. And it's true. It does. So what you need to do is start going through segment by segment. So going from 10 to 20. If you just pick whatever the middle points on your on each of those, you can see like this goes from here to here. It looks like it's going down. This looks like it's going up and down. Would this part right here be linear? We can try it and see. And this is the part where you're going to have to maybe play around with this a lot. So what I'm going to do, I think this is going down. I think these are all going up, and then I think these are going down. So I'm going to see if I can make all of these one graph, and if that looks okay, I'm going to make these separate plots. Okay, so here's my plan. I'm going to do this as one set. I'm going to do this as one set. And then I'm going to do that as the third set. Okay, so these are the three series that I'm going to try and graph, and we're going to see how that looks. Okay, so let's pop back, go back to our graph, highlight the graph. Let us go to select data. And I am going to delete our thing that gives us the whole data set, because that's not very, very useful. And I'm going to do, again, the x values. Oh, we need to add a series. This first set, the x values are going to be, we're going with this one. So it's going to be these. And the y values are going to be these. And then we need a series whose x values are these. The y values are these. And then you need a series whose x values are these. And the y values are these. So now we're going to go through and we're going to click on the first set, and let's throw in a trend line, and we can go ahead and put the equation in the r squared. You can see that this is not a great r squared, but because this is the smallest chunk we can do, there's not much we can do about that. The last set, I'm also going to add a trend line. Now, let's do a trend line for our middle set. Okay, so what I want you to think about, anytime you do more than 2 chunks of data together, so in this case we're doing 3 chunks of data for our middle set, is think about, is it better as one contiguous line, or is it better if you break it up into sets? And so you may have to play around. I think that this trend line is more or less going in the right direction, and it's starting, passing through, and ending near at least one of the data points in your data set. So that's probably as good as we're going to get. I don't think breaking it down might be a little better, but I think you could probably just go with this. So let's say you end up with a buret correction plot like this. Let's just kind of zoom in here. And let's talk now about how to use it. So let's say that you are doing a titration and you dispense 37.26 mils. Okay? Let me actually do this. 37.26 mils. Now notice I put the number in one cell and I put the unit in another. That is because if you have a unit in the same cell as your number, you cannot do calculations. And we're going to use this number right here to do a calculation. So if you look at where 37, you know, one thing I didn't do on this graph is I did not put labels on. And since I don't remember which of these are supposed to be, okay, so when you did your titration, your math tells you that you added 37.26 mils to your Erlenmeyer flask. Okay, so that is your apparent volume. And you have to now think, what does that mean for the actual volume? Okay, so we want to calculate actual volume. And right now, of course, that is a question mark. So what we're going to do is we're going to do find the correction volume for 37.26 mils. And we're going to then calculate the correction volume using this graph and use that to calculate the actual volume. Remembering that actual volume equals apparent volume plus correction volume. Okay, but what is the correction volume? Well, in this case, we have 37.26 mils. And if you were to look at this graph, that would end up, you know, the apparent volume would be somewhere in here. And the important part is it would fall somewhere along this line. Okay, so we need to use this equation right here to determine our correction volume. So y equals 0.0089x minus 0.3065. Okay, so y is our correction volume, and that's going to equal 0.0089x. What is x? Well, it's our apparent volume. So we're going to do times this volume minus 0.3065. So there's our correction volume, and you can see that our actual volume goes up just a little bit.